Cool. Okay. So yeah, so our team D was the module that we got as object detection module, and all the steps that we were supposed to follow are listed here. The first that we did was dataset collection, that we obtained frames from the video, and then we annotated using label me and obtained our XML files. Then we converted XMLs to CSV file because they have all the coordinates or bounding box that we performed in annotations, and then we'll split our datasets into train, test, validation datasets. And after that, what we require is a Tensorflow record file and also a label map which will generate. And I think some nice. Okay. So then we can take some pretend model, or we can train our own also for generating model checkpoints, and we require a YML configuration file for Google Cloud. Where we found the model, cool. And yeah, and we'll train and we'll finally export the graph for and then inference at last. So the annotation part that we did, you can see here, we annotated the images. And yeah, after annotation, what we have to do was we had to convert it into I mean you need XML file that you collected from label me, and you will just pull it there. I'll show you here. This is the XML file. Then after that, we had a script like train test split.py, using which you can split your data sets into two different training parts and testing part. And that is what we did here. And you can see our data sets divided into training and testing. This is the test set with around 11 images with 11 XML files, their corresponding XML files, and also training images with 50 images with 50 XML files. Okay, some of my exam. Okay, and then after that, what we did is we converted this XML to CSV. This is an XML file, and once the XML file consists all information about the annotation that we performed on images, information regarding the object, their position in images. Suppose if there was, you can see, suppose if there's a vehicle on the image, so at what coordinate it is at what coordinate we did annotate it. So we need to convert this XML into a CSV, and your CSV file. Can you not hear me, or is there an issue? Okay. Any problem? Cool. Okay. Then yeah. So then the CSV file that you will get consists all the coordinates of the images. Somebody was asking how to how the images will, if there is blockage in images, if one object is blocked by another object, how would it determine? So that is actually all the coordinates are stored here in your xmin, ymin, xmax, ymax. And then what we do is we go for I'll show you. Give me a second. Yeah, so yeah, because it consists of all the information about your coordinates in bounding boxes, and that makes annotation and tracking of the object easier, and further segmentation also can be done in it. And in process means after since I'm getting some error on generating TFR record, so I have been talking with Devin in this matter, but since there is some problem with my code, so I am talking with him, and I'll do that part. And yes, the future enhancement, I mean the future steps that we will be doing will be generating TFR record file and also label maps, which is required. And then we'll train our data set, and once we train, we'll obtain in graph so that we can use it for inference. And to answer the question, if the image is if the object is covered by another object like this, so what we can do? So suppose I think you were absent during annotation. So what we did was if we have an object motorbike like this. So we annotated, labeled, we annotated the complete bike, and we imagined, okay, so this is the the obstructed path. So once you do that, you can implement a lot of algorithms. There's one of which is PCA. Also, you can do feature extraction. How it works is, suppose if it is, if it is covered, you can find intersection, and you can also find union, and the ratio between them is your accuracy score, and then you can select if you can predict whether it is a bike or not, only while looking the first half also. So that is what we can do, and I think that's pretty much from me. The next step would be generating TFR record file for our team and training the data set in the GPU, which we will do after this step. Okay, thank you. Any questions? Okay. Yeah, any questions you can ask?
Okay, thank you, sir. So actually, can you please explain that part? Like, how do you plan to recognize or detect any object when it is overlapped with like another one?
Okay, cool. I'll tell you. I'll show you. But okay, give me a minute. Okay.
Yeah.
The thing is, suppose, okay, let me show you this image only particularly. So this one, right? So the thing is, once you have an image, or once you have an object, obstructed by other object on the screen, what we can do is, I'll show you on the detail. What we can do is, give me a second. Let me see here. CNN. So, okay. So I got the content right. Yeah. What we can do is, suppose this is an image, right? It's an image. It has no any obstruction, but you can imagine a baby standing on the ground, right? So while using coordinates, what we do, we separate, we divide the image into different parts like this, and then we feed each image. You can see this is the first input tile here, and then we apply. That is how your neural network works, right? That is how we apply this particular input file, and then we generate an output. And so similarly, all these slide will be passed through a small neural network, and an output array is generated. So same case can be done in that particular image also here. Once you send this image, it is divided into, it's not passed as a whole. It will be divided into its constituent part. And also there are different things like segmentation and all, but that will come in future. But what I would add here is, once you do divide like this. Once you divide like this, you can use a small neural network, and then you can generate output array. So from that you can predict if the image is bike or not. So you don't have to have complete complete view on your image. You can predict using this also. So if you have anything else, you can ask me again.
Okay, but like there may be some cases where like that patch actually, like whatever you will be taking from that image, that object which is obstructed by another one. So like in that case, like is there maybe any kind of chance that neural network, trained neural network can't be able to recognize that as
yeah. So the thing is, once I haven't actually showed you the whole, everything I haven't showed you. If it will take time, but I can show you. It doesn't matter. This is how if you are recognizing something, this is how you divide it into pixels, right? So then you load that pixel as a matrix, and then you pass it to your neural network. So what it is done is it applies filtering on that. So once you divide like this. Once you divide your image like this, then once you send your input tile, one input tile to your neural network, it will generate an output. That means you have a lot of input tiles here and lot of output array. Then what you can do, you'll go for you'll get an array. This array is nothing but your output. You can see here input array telling if this is an output, right? So you have an array from convolution and step 3. This is step 3. So once you get that, we can go for max pooling. Max pooling, what it does, it will, suppose you had a bike in that screen, right? So if it is a bike or not, it will, the pixel, the max pooling means it will take the maximum pixel. If it is, suppose in this image you can see, this particular image, in this particular image, this tile is contributing to bike, this tile is contributing to bike, this tile, that is a headlight, is contributing to bike. So there are lots of, number of tiles that is contributing to bike. So that means while
Yeah.
max pooling, what happens is that you will get here that max pooled, that value you will get here in max pooled array. So once you have max pooled array, then you require a fully connected neural network. And if your max pooling consists of, if your max pooling has information about a bike, there are two bikes on your, you can see here there are two bikes on your images. So if your max pooling has that information, it is obviously, detected by neural network. So you'll likelihood, it is a likelihood, it is a match, you'll get that match in your image also, right? So this is actually on algorithm level, but again there are a lot of things. PCA, someone is asking, PCA is actually programming component analysis. You can use that, but since it is, you can use it, since that's why we did a bounding box on a complete bike. We can't see the complete bike here, but we imagine the bike is there, and we did this. So yeah, there are a lot of things, but yeah, I can answer that. Yeah, if you have anything, you can ask again.
And like for that patch, like whichever you will be taking from that like input image, so the size of the patch and like where we should first like picking those patches from the images for the detection. So
Okay.
is there any kind of any algorithm or any kind of method, or you will actually randomly like take those patches from the
Yeah,
image?
that's a good question. Actually, that's a good question, because we that was the question I asked during annotation part. The thing is, once you annotate your image, so you if you have used label me, you can, you can intersect, you can overlap this one patch with another patch. Now this patch, what does it mean? Once you do this in label me, you will get an XML file. That XML file will have this point, this coordinate, and this coordinate. So that means your one motorbike image is this whole image along with this content, but another your bike image is this whole image along with this content. So that means this object is, you mean this object is obstructing this one, right? So what happens is that that's why we converted this to CSV. So you can see it's in CSV. CSV has your x min, y min, those bounding box coordinates here. It doesn't work. There's nothing like overlapping. Your images will have pixels. That pixels is in 2D, right? Images in 2D. So you have the original of the pixel, your x-axis minimum value and y-axis minimum value, x-axis maximum and y-axis maximum. So it will count that also for this portion of this object bike, motorbike. It will count this one also. But since your image, in the total image, if you divide it in tiles, there's more probability of being it a motorbike, right? Rather than it may look like an animal, but it isn't, because the once you divide it in number of tiles, the maximum number of tiles has is predicting that this is a bike. This looks like a bike because it has a headlight. It has a mirrors, and then there's a wheel. So this is also, we'll do segmentation later. So I think we will understand there also. But yeah, there are algorithms, but this is how I think I can make you understand.
Yeah. Okay.
If you want to see, you can just later you contact me. I can show that, because there is an in level me, you can do that if it is abstracted. If you are annotating some images, so you can do that. We have done that. You can see all the images here, and then you will understand. So some of the images that we have annotated, you can see here. So once you do that, suppose if you want to see, I can show you. I think here it is. Okay, cool. So this will come to again convolutional neural networks, basic and convolutional neural networks. You'll understand there also. But what we did while annotating only, we annotating, there is an option, as someone told. Yeah, you have given selected there that this object has been obstructed. So accordingly it will read. Yes. Okay. Cool. Cool. Okay, yeah, that can be
Yeah.
done. Okay. Thank you, guys. Any questions, sir? Thank you. Thank you, guys. So I'll stop sharing. You can take over.
Yes.